My name is Mohamad Bayan. I'm a solutions architect with Verizon, and my topic today is about microservices and the service mesh. Um, the theme for this conference is Journey to Microservices, and we've heard about microservices in the keynote. We've heard them in the different speaker sessions. So we can start off by saying, let's say, who's building, designing, maintaining, testing, operating, anything to do with microservices? About half, okay. So for those who raised their hands, in your current microservices architecture, can you support polyglot microservices? Basically building the services in any language, whether Java, Node.js, .NET Core, you name it, Python, and have them all co-live and exist as a single application. Can you do that today? Couple of hands. All right, cool. So microservices has been a really hot topic in the industry in the past few years. And a lot of organizations are migrating from monolithic applications to microservices as part of going to the cloud and part of the digital transformation, as Margaret mentioned in the keynote this morning, right? The quest to digital transformation. You have cloud first, and you have speed to market and faster innovation. And also a part of that, you're trying to build cloud native services that you take to the cloud, and you want to reduce cost. So we're migrating to microservices due to the claimed benefits that they're easier to build. It's a small service. I can build it even to the fact at any point I can scrap it and rebuild it from scratch if I need to. They're independently deployable, right? Each one of them is in its own entity. I can deploy it separately. I got precision scalability. Since they're independent, I can scale each one based on its own requirements. I get technology diversity, right? And the concept here is basically I pick whatever technology and framework that makes the most sense for that specific business use case, and I build my microservice in it. I get fault isolation if the system was designed and implemented properly. If something happens to one of your microservices, it shouldn't impact the rest of your system. And it's easier to scale development with microservices, and this goes back to the concept is I have a product team that owns one or multiple microservices, and they have their own destiny. If I want to scale that, I add more product teams, they own a different set of microservices, and so on and so forth. So the question now, do you truly realize the benefits or these benefits the way you're building microservices? Do you truly achieve all of these the way you're building microservices today? So let's try to answer that. So as it was mentioned, right, in different sessions today and yesterday, we're going from monolithic applications to microservices. We used to have a single process, big O app. Anytime we made a change, we have to regression test everything. It's hard to scale it up. We have to worry about performance. You get to the point, regardless how many resources you add to your dev team, you can't improve speed to market, and so on and so forth. And we're saying we go into these small microservices, and we just discussed the benefits, easier to build, technology diversity, precision scalability, right? Where does the complexity go? The complexity does not just disappear. So the fact that you're going from a single process to a set of processes, you have a distributed system. And in order for you to build and deliver and operate a robust distributed microservice system, there have to be certain capabilities in place. Things like service discovery, right? How does service A discover service B? Service routing. If a request comes into your system, how do you route it to the right service or right instance of the service? East-west load balancing, configuration management, secret management. Monitoring becomes more complex. You have to monitor one process. Right now, you monitor multiple processes. Logging becomes more complex. You were logging from a single process, single file. Right now, you have a lot of processes all spitting out logs. You have to centralize it for further analysis, and so on and so forth, right? Distributed tracing becomes a must-have. We know all of this. So all these capabilities are needed in order for us to build and deliver a robust microservice system, and that's where the complexity goes to, into the distributed system. So now, these capabilities at the services layer, plus capabilities needed at the API layer, right? And capability needed for the purpose of build and deployment automation. Think of your CI/CD. So all these capabilities in the yellow ovals, right? We call them, or Gartner calls them, the outer architecture, right? How you build a single microservice, whether you build it in Java, Node.js, Python, you name it, that's your inner architecture. So a microservices logical architecture is an outer architecture plus an inner architecture. So this is more of kind of we all know this, kind of rephrasing or re-summarizing the microservices logical architecture. So now the question is, in your current architecture, how are you solving for the outer architecture? Well, most likely, you don't want to custom build it yourself, right? So most likely, you bring in an open source framework or toolkit to solve for service discovery and service routing and east-west load balancing and configuration management and so on and so forth. There are a lot of good ones in the industry. Some of the common ones is, of course, the famous Netflix OSS, Spring Cloud, wrapper on top of Netflix OSS, Play and Akka, and there are others. So you bring one of these frameworks or toolkits, and you bring them so they can implement these on your behalf. So you got one of those. How does your individual microservice consumes or make use of the capability you brought by that framework? Well, you have to add a shared library or a network client inside each individual microservice in order for your microservice to consume the capability provided by that framework. And this is what's indicated by the purple layer right here. This is basically your libraries and network clients that you have to embed in each individual microservice. If you think of service discovery, I had to add a client inside my microservice to consume service discovery. But some in the industry, they call this a distributed monolith. Basically, you took your monolithic application and you spread it over the network, and you coupled it by binary dependencies. Okay? So what are the challenge or what are the observed outcomes and behaviors of distributed monolith? Well, number one, you have temporal coupling. You have a coupling between your service and the outer architecture. A service cannot exist in your system unless if you add that layer of binary dependencies, the network clients and the shared libraries. Number two, you have operational complexity. Imagine you change your service discovery, and that requires a change to the client that comes with it inside your microservice. You just impacted 100% of the services in your ecosystem. That's operationally complex to do because you have to do that upgrade in lockstep. Number three, you have technology limitations. When we talked about the benefits, we said one of the benefits is technology diversity. I should be able to pick any technology I think is the most appropriate to solve a use case. I can't do that anymore. If I'm, for example, in Netflix OSS Spring Cloud, I can only build Java services. I cannot get a Node.js service and drop it in there. If I'm in Play and Akka, I only build Akka actors. So I lose that. I lose the ability to embrace newer technologies. And number four, you have organizational technical coupling. And this goes back to the concept we were talking about, right? You have a product team that owns one or multiple microservices, and they should be responsible for the whole life cycle of that microservices from a technical point of view. But you can't do that anymore, or you lose some of that flexibility. Why? Because the outer architecture usually is owned by a team. Usually we call them the platform team. And whenever you have to make a technical decision that would impact how you live in that system, you have to go back to them. You can't change your concurrency model on your own. That would impact them. And anytime there is an impact on that outer architecture, it has a further impact on anybody else who's building services. So you have to do more kind of impact analysis. What does that mean of that change? So you lose some of the characteristics of microservices, which is decentralized governance. So how do we avoid the distributed monolith? Well, we should only depend on data contracts and network protocols, and nothing more than that. This is how the internet works. And this is the premise of APIs. We should be exposing our foundational capabilities as APIs, hiding all the implementation details behind it. So just to clear this up, are we saying what everybody's been doing wrong? No. So remember when Netflix started with the microservices journey back in 2009, 2010, they were going to the cloud, AWS, and at that point it was EC2 instances, right? So virtual machines. Their abstraction was at the OS level. They had no option but to build the outer architecture capabilities themselves. Same thing Akka was in 2010. But since then, there's been a lot of advancements in technology, like Cloud Foundry in 2011, Docker 2013, Kubernetes 2014, right? And then you have serverless compute in 2014. In the past couple of years, right, you had the concept of a service proxy as a sidecar and the concept of a service mesh. So what we're saying is, or what I'm saying is, if you're building microservices, most likely your strategy will be different since there's been a lot of advancements in technology in the past 10 years. So in other words, right, your abstraction on top of your infrastructure will also determine your strategy of how your auto-architecture implementation should be. So if you are at an infrastructure as a service level, which was where Netflix went, when Netflix went to the AWS, right, and they start building their microservices, you have to solve everything yourself. But if your abstraction is container as a service, or a platform as a service, or even function as a service, right, you have more abstraction on top of the infrastructure, and then you get more capability from the platform, whether that a PaaS, a CaaS, or a FaaS, that you should be leveraging when you build microservices systems. And we're no different. We started our microservices journey at Verizon a few years ago, and we ended up with multiple tech stacks. So just like any big enterprise, you have multiple organizations, and because you have multiple line of businesses, and we have decentralized governance when it comes to application architecture. So they ended up picking up different technologies and tech stacks to solve for the outer architecture. And also other reasons that kind of in some scenarios we ended up with different tech stacks with different teams within the same organization. For example, team A would go pick a tech stack, and team B would come in and say, okay, I want a different programming paradigm. The tech stack that you've chosen already does not support it. I'm going to introduce a new tech stack. And we've seen it, for example, with reactive programming. In some cases, the decision is influenced by the team past experience and what language they're more comfortable with. So for example, if you have a team who's been doing Java for 10 years, it was much easier for them to pick something around the ecosystem to solve for the outer architecture. Or somebody who's been in .NET, for example, it was easier for them to pick something else. So bottom line, we ended up with multiple technology stacks. But what did that mean? That means we had silos. We had silos with different technologies. All of them were type of distributed monolith. And then we ended up with multiple ecosystems. So because these are built in different tech stacks, they couldn't coexist as one system, right? Think about it. If service A in tech stack 1 wants to consume service B in tech stack 2, it had to go through the service gateway because they cannot use the same service discovery. Even more, the concurrency model could be different. The programming paradigm could be different. So we ended up with multiple ecosystems. That had the implication of cost, right? So basically, we were solving for the same capabilities in different technologies. Licensing and support, you need it for different tech stacks. Resourcing and upskilling your resources and skill set that you need is different. And even in some case, tooling. We would bring in an APM tool. It would do a really, really amazing job with tech stack 1. Not so as good with tech stack 2. You bring in another APM tool, it do the opposite. It will really do a good job with tech stack 2, but not 1. So then the question, what do I do? Do I onboard both APM tools? So we had these type of challenges. And of course, we talked about operational complexity. We said it's complex. It's operationally complex to operate a distributed monolith. Well, we had more than one, so it's even more complex. We needed to achieve tech stack alignment. And this is also aligns with basically what Margaret was saying in the keynote this morning, right? Speed versus stability. And they would say tech stack, if you align a tech stack, it can help you scale better, right? So we wanted to achieve some tech stack alignment. We wanted to reduce cost for sure. Along with that, we wanted to come up with a strategic architecture that would also avoid the distributed monolith, where we can truly realize the benefits of microservices. We had an opportunity. As an enterprise, we were adapting the public cloud. We were looking into container orchestration. We were looking into function as a service, serverless compute. We were investing in cloud migration, and we were investing in application modernization. So we wanted to use that opportunity to get some type of alignment. But whatever strategic view we wanted to come up with, it was important to minimize the impact to the existing applications and teams. And it was important to maintain inner architecture decentralized governance. We wanted the team to still decide how they build business microservices. We did not want to get into saying, this is the only way to build business microservices. So, like I mentioned, we were looking into container orchestration, and Kubernetes is becoming the de facto standard for container orchestration in the industry. And we were looking at Kubernetes and others, but we were investing more effort into Kubernetes. When we did more deeper dive analysis of what capabilities we get out of the box, we were able to solve for the top ones: service discovery, routing, load balancing, east-west load balancing, secret management, configuration management, unlogging as a platform services, whether you get it out of the box or whether we complemented it a little bit with some work on our side to make it a platform service to all of our app teams. So any application that wanted to migrate into the container orchestration ecosystem, the message was try to decouple yourself how you did service discovery, how you did service routing, and try to take on the capability provided to you by the platform service. So the beauty of that is Like we were saying, these services, they are decoupled from these, so you can build the services in any language that you think is appropriate because you're not adding any binary dependencies here. So this was a good first step, but we also wanted to solve for the other capabilities that are still not unsolved for. And we wanted to solve in the same manner where we avoid the coupling between the service, the inner architecture, and the outer architecture. So imagine the following. Imagine if you can take all these capabilities, right? Add them, put them into a process, and have that process set right next to your service, transparent to your service, and it will address all these cross-cutting concerns. This is exactly what a sidecar pattern is, right? It's a process that would be attached to your parent application, in this case, your microservice, in order to extend and enhance your parent application. So if you take all of those, service discovery, load balancing, traffic management, circuit breaking, all of it, put it into a process as a sidecar, and have that sidecar act as a service proxy to your microservice, that microservice can be built in any language technology you want to. It's transparent to it. But then, if you do this to every individual microservice in your system, you end up with a service mesh, right? And Lakshmi from Google introduced the service mesh in the keynote yesterday, right? So it's nothing but a configurable infrastructure layer that would make the network transparent to your microservices application. And as it was mentioned in the keynote, the goal is to connect, secure, control, and observe your microservices. All right, perfect. So I have the service mesh. I have my services. They have a proxies right next to them. I can build the service in any language. But these proxies need to be configured, right? I need to collect telemetry from these proxies. I need to monitor these proxies. Most likely, if you have hundreds or thousands of microservices in your system, you don't want to manage them individually. Most likely, you need a control plane. And that's a typical service mesh architecture. In this case, this is Istio, which is an open source implementation of a microservice. What Istio is doing basically is just building the control plane. This is, again, your service, your proxy as a sidecar. This is called the data plane. Default implementation is Envoy by Lyft, but any other implementation can be used. Istio is building the control plane, which is how do I handle configuration data to my proxies, how do I do policy checks and collect telemetry, and how do I manage TL certificates to my proxy. So if you put it around, if you try to put it all together, right? What we're doing is between the container orchestration, in this case Kubernetes, and a service mesh like Istio, you should be able to solve for all of the capabilities that you need at the services layer. And all of this is decoupled of how you build a single microservice. And this is what we call Microservices 2.0 at Verizon. This is basically the next architecture we're trying to follow and we're trying to do. So the advantage, like I said, is this is decoupled, so you're not adding any binary dependencies, and this can be built in any language. To make sure that we are doing exactly that at Verizon, so we took the architecture and we built a reference implementation around it. It's more like a sample use case along with the wiki for us to agree on the best practices and standards. It's kind of inner sourcing type of thing where different team members can involve and participate to it. So we are a telecom, so we deal a lot with devices and plans and reviews and ratings and accessories, right? So we built 6 services, and we built them in 4 different languages. We use Java, Spring Boot 2.0, Spring 5, and we built it in different programming paradigms, object-oriented and reactive programming, and Tapaneri and Tomcat. We built one in Go, we built one in .NET, we built 2 in Node.js. The reason we did this, we're not telling the teams you go do exactly that. All we're trying to make sure is how the approach that we solve for any of these capabilities has nothing to do of how you build a single service. We're trying to make sure if I solve for service discovery or secret management, I'm not embedding anything specific to Java, or I'm not doing anything specific to Java. And we didn't only do it at this layer. Even for the build automation and the deployment automation and the CI/CD, we build it where it works with any language, any framework, even our APM tooling, we're looking into it to be able to support any language, any technology. And we open source it, like kind of open source it internally for other teams to contribute and consume, and also for them to come back and improve later on if they find a better solution or a better option. So to kind of wrap it up, I want to just share a timeline for service mesh, because I think this is going to be one of the next, architectural patterns that everybody's going to jump into, just like we did with Kubernetes and microservices. So it started back in 2016 with Linkerd, and then Lyft open sourced Envoy in September 2016. At that point, they had spent about 1.5 years building and putting it into production. IBM, Google, Red Hat, Lyft came together and they started Istio 0.1 in May 2017. There has been a huge push in Q3 of this year. Basically, Google Cloud announced they will have a managed Istio service as part of their Kubernetes service. Red Hat announced OpenShift service based on Istio, part of their OpenShift offering. Azure Service Fabric Mesh is not based on Istio, but it still utilizes Envoy as a sidecar. IBM announced that it will have Istio managed service part of their Kubernetes service. So you can see where this is headed. Just like Kubernetes, right now you can get Kubernetes as a managed service from any of the top public cloud providers. I expect the same. I expect along with Kubernetes, you will be getting a service mesh, whether Istio based or not, as a managed service from your top public cloud providers, which means onboarding a service mesh and starting to utilize a service becomes a lot easier. And I think this is the direction we're heading into. So to summarize it, if you're building microservices or if you're assessing how you're building microservices, I would say don't build them at the 2009, 2010. Try to leverage the platform. Hopefully you look into container orchestration, and a service mesh as an architectural pattern. Try your best to avoid the distributed monolith, because at that point you can truly realize the benefits of microservices like technology diversity and the ability to embrace newer technologies easier. And that's all what I have. Thank you so much. So we can open up for any questions or comments. Yes, sir.
So I have two questions.
Sure.
I'll try to get the most important one for me first.
Sure.
How do you leverage teams that want to use your platform infrastructure versus teams that want to go to AKS or EKS?
Yeah. So we're trying to get a tech alignment or tech stack alignment when it comes to platforms, and we want to open up when you want to build business logic. So this goes back kind of to the concept saying anything in the outdoor architecture, we're trying to align on it, but how you build your business service, I don't want to get into that business. So from a platform perspective, when we started our journey with Kubernetes, AKS was not in the picture yet. And I mean, it's publicly announced Verizon is adopting AWS as our primary cloud provider. But we knew at some point they will pick it up because it's becoming the de facto standard in the industry. So we invested effort into the open source Kubernetes, and we ran it ourselves. And we made it a guideline. Well, at some point when you have everything ready, all app teams are going to be like, the easiest way for me is to just get onboarded to what's already existing. I'm not going to go build my own platform because it's not an easy task to stand up an open source Kubernetes at a scale. And on parallel, we are evaluating the managed service offering from AWS. And at some point when it meets our requirements, I mean, it will be much easier to operate a cluster when they handle the masters and everything around it instead of us doing it. But it's a strategy that we keep looking and evaluating and assessing. But we tell the teams Kubernetes is the way. We don't want anybody using any other container orchestration framework. So far, we are investing in open source. At some point, we'll keep evaluating the cloud offering. Whenever it's ready for us, we'll consume it. Does that answer the question?
You guys mind if I do one more? Sure. How do you handle billing back to the project teams in different businesses?
So what we did, just like we do with the cloud, right? You have to create logical separation, right? So we achieved that when we go to the cloud. We wanted to achieve the same thing when we go to Kubernetes. For example, if you deploy an application, I deploy an application, I shouldn't be overstepping your application. I shouldn't be accessing your data. I shouldn't be doing any of that. We did the logical separation at the namespace level. So we got a solution where it integrates with SSO. And then, so when you are, for example, part of the SSO system, you get a group assigned to your app. And when you log into the cluster, we see what groups you belong to. You tell us what namespace and whether you're authorized or not. All your application goes by your app ID and all the metrics information about what you're deploying, how many Docker images, how many instances, what's the resource usage, all of that information becomes linked to your app ID, and then we can have that metrics available for the purpose of billing and further analysis. But the separation is happening at the namespace level, even for security purposes.
Yep.
Yes, sir.
I suppose you're running Istio and Envoy in production.
We're not in production yet. We're almost there. The plan is we started looking at it, and again we got early on because we wanted to be strategic of what architecture we pick up as we try to align the teams to go forward. So we looked at it early on last year. Right now we are looking at taking a pilot app, a small app with a slice of traffic to it. We're trying to get comfortable operationalizing it in production. and make sure we have the right observability. We make sure we have the right toolings around it, collecting the right logs. If something goes wrong, we know exactly where to go look. So we're trying to get comfortable from an operation perspective. I'm pretty sure we don't have any issues with the sidecar. So right now the default implementation is Envoy. It's battle tested by Lyft, right? And it's open source. A lot of teams took it to production already. We're trying to get more comfortable with the control plane and make sure we can stand it up in production and kind of support it. Yes, sir.
You mentioned good multiple tech stacks. Did any of those include Windows computers?
We didn't get to the Windows container. When we had multiple tech stacks, that's when we were still on-prem. And we did have .NET, we did have Java, we did have everything, but it was all on-prem. So when we were trying to align, at the same time, we were going to the cloud. So we used that as an opportunity to say, let's align as you migrate, because we are investing in the cloud migration and putting money for you to modernize it to be cloud native, right? So if you're doing so, might as well align to this new tech stack. So at this point, we never had introduced the Windows containers yet. Any other questions? Yes, ma'am.
When you were migrating from legacy on-prem installations to this new infrastructure and architecture, when you were in transition towards that target, did you make a decision to just rewrite everything, or did you combine legacy with the new in some
Yeah. Yeah. So when we initially started, the first few apps, they were kind of refactoring to make them cloud native. But then we looked at it as like, this is going to take us forever. And one reason that you bring in a cloud is for you to save money, reduce cost. And to reduce cost, you have to shut down some of your on-prem resources. And the speed that we were going, we will never get there. It will take us forever. So the plan is, for example, we have to do an analysis on each application and look at it, how strategic the application is and what are the futuristic roadmap for it. Some of them, yes, we want to invest and refactor. Some of them we want to lift and shift. Some of them we just want to tweak a little bit. Maybe get rid of your database and connect to a different database or a different cache, but keep your code as is. So it's a app by app based analysis. There's no way we can refactor everything before the cloud. Before going to the cloud, we won't meet our business goals that way. So it was a mix. So we were pushing for lift and shift. Perfect. Well, thank you all. Thanks for attending.